This is problem 3 on your practice exam to find the value of the linear correlation coefficient R. So I went through and I went ahead and entered it as into two lists. So I did L1 was my performance, and I entered L2 and made that my attitude. I had 10 entries for each, and then I went through and did a linear regression t-test, and I found that I really didn't do an 8-step here. If you want me to backtrack here a little bit, my HO is my null hypothesis. That is rho equals 0. H1 rho does not equal 0. And if you remember this rho, this means no linear regression. I'm sorry, no linear correlation. And if rho does not equal 0, that means there is a linear correlation. So that would really be starting with step 3. Step 4 would be alpha equals 0.05. Step 5, I'm going to do the linear regression t-test. So it's the t-test statistic. Okay, and then number 6, once I put in my data in L1 and L2, and I go through and I do the linear regression t-test, then I calculate R. I will get my R test statistic from that, and I got R equals 0.8632. So that's what's asked for in part A, I guess. Yeah, so that's 0.8632, so that would be answer A, where it says 0.863. Part B says show a scatter plot, but I'm going to first finish this out. So I also, when I calculated this, I got P equals 0.00129. Now I can just use the p-test, and I will get the p is less than alpha, and that means I reject my HO, which means there appears to be a linear correlation. So if I reject my null here, then there's a good chance that the opposite is true, so there is linear correlation. Okay. Now I could also go through and use the RT test, and I could go through, or I'm sorry, the R test statistic and compare that to the critical value. I did not do that here, but if you want to go through and do the critical value, you will get plus or minus 0.632 because you have n equal to 10, alpha's 0.05, and then you would use table A6 to get that, and then you compare. Your test statistic is greater than the critical value, therefore I'm going to reject the null, so I will get the same conclusion as I do with the p-test. Okay, then part B asks me to draw a picture of the scatter plot. So if you remember how to do that, you'll do second y equals. You'll press that, and then you can get to your plot. You can make sure you select the appropriate lists and turn your plot 1 on, and the other ones need to be off. You go through, the first type is the scatter plot. Go through, go ahead and graph it. You can do zoom 9, and if it doesn't appear, then hit graph. And then he wants you to label the axes and all, so make sure this is the x-axis, the horizontal, and this is your performance. The vertical axis is y, this is attitude, and then I would go ahead and mark off some scales, whether you do every 5, every 10, however you want to do it. And I got something like this. This isn't going to be real accurate here. I don't know, I got something like that. But you can just check with your data what you entered, and you can even do it manually without using the calculator, just looking at the points on the paper. Okay, so then for part D, if a performance score was 72, what would the prediction be for the attitude score? Well, when I did my linear regression t-test, it's where they'll give you the A and the B equals, and I do my Y equals A plus BX, I think it is. So in this case, it's that Y hat thing, and I got 11.659 plus 1.0215x. That's the equation, the regression equation. And because there's linear correlation, I found when I did my p-test, this is a good fit, or this appears to be a good model. I'm sorry, this appears to be a good model to predict the performance, or I'm sorry, to predict what the attitude score would be. So if a performance score is 72, I'm going to just plug it into this equation. So I'll get 11.659 plus 1.0215 times 72, and then I get just over 82, I think 80, or I'm sorry, just over 85, 85.207, so I'll just make that 85. And there's a, let's see, what page was the chart on? There's a chart that talks a little bit about this, whether or not you use that equation. Oh, page 521. Just refer back to that chart again. If the regression equation is a good model, then go ahead and substitute it in the x value into this equation to get your y value. And then if this were not a good equation, if there were not correlation, then we would use the mean value of y, which in this case was given, let's see, was it given? I don't think, actually it wasn't even given in this case, but if it were given, then that's the value we would use. But we want to use the linear regression equation line. Okay, real quick for the next one, number 4, we're given that the correlation coefficient between two things is negative and close to 0. So the conclusion that they arrived at was people who score high on the math test tend to score low on the athletic ability test. So if there's a negative correlation, it would go like this. So as one goes over to the positive, if I start here, as one value goes up and gets higher, the other one gets negative. So it's sort of an inverse relationship. As one increases, the other one decreases. So it's saying if you score high on the math, you score low on the negative. You score lower on the test athletic ability. But first of all, there's not linear correlation. So really we can't make any conclusions about it just because the R is a negative value. But it's very close to 0. So it could be a 0.001, for instance. And because this is so close to 0 and there's no correlation, if you look on page, back to those graphs of the scatter plots, let's see, on page 497, you'll see that if there's on part D, there's a negative relationship of minus 0.087, and it does something like this. So there's no correlation. So actually these points, they both increase. It would make me think that people who score higher on math tests do better on athletic tests. But as you go down this way, you get the opposite. But we really can't draw any conclusion because there's no pattern of linear correlation. And there's probably some other ways you can write it too, but the linear correlation coefficient, the R, it's only a measure of the strength of the relationship. So if they are correlated, then you can use it. But when they're not correlated and they're close to 0, we really can't draw any conclusions about it. So, and you may want to ask Jack or check his answers for a better response than what I came up with there.